I'm Dr. Denise Hurd, Director of Research for the U.S. Poultry and Egg Association. With me here today, I have Dr. Brian Jordan. Dr. Jordan is an Associate Professor at the University of Georgia within the Departments of Population Health and Poultry Science. Today, we will be discussing one of his recently funded U.S. poultry projects titled Utilizing Dry Hydrogen Peroxide as a Replacement for Formaldehyde in Commercial Poultry Hatcheries. Welcome, Dr. Jordan. Congrats on your funded research project, and thank you for agreeing to chat with us today.
Yeah, good morning. Thank you for having me.
So let's just jump in, Brian. Hatchery sanitation is a continual issue in commercial poultry and has become a focus since the removal of antibiotics from the poultry industry. Poor sanitation in hatcheries can lead to reduced hatchability, increased 3 to 7 day mortality, and chronic infections, which can reduce performance. Your project proposes an alternative to formaldehyde fogging. Can you provide an overview of your project and explain why an alternative to formaldehyde fogging is really needed?
Sure. So this project is sort of the culmination of a series of projects that we've been doing here over the last 5 or so years, working with a dry hydrogen peroxide technology from company Synexus. This dry hydrogen peroxide actually creates a peroxide molecule, but in a gas phase. So it's not the liquid peroxide that many of us know right now. And so we've been doing this incrementally, looking at the ability of the dry hydrogen peroxide to combat and destroy microbes in different environments, sometimes just in egg coolers, on surfaces of eggs, in different locations within the hatchery. But now we're taking it to the final step where we actually want to supply the dry hydrogen peroxide directly into the incubators and into the hatchers, giving maximum contact time for those peroxide molecules that are being developed to combat microbes both on the surface of the eggs when the eggs are placed in the incubator, but also as we get that microbial bloom in the hatchers as the chicks begin to hatch. Now, the reason that we felt like this was necessary is if we go way back in the poultry industry and look 40, 50 years ago, formaldehyde was very common, it's commonly used. But as we move forward in time, the use of formaldehyde to try to control these microbes, these bacteria, and fungi, particularly in the hatch phase, began to decline as we were able to use antibiotics in our feed and help control some of those bacteria on the grow out side. But now over the last 10 to 15 years, as we've been continually moving to an antibiotic-free production system, some of those disease states, some of those bacterial issues that we didn't have to deal with are starting to come back. And so formaldehyde fogging in the hatcher to try to control those bacteria is starting to come back as well. Now, formaldehyde, for what it does, is a great product. It is very effective at killing those microbes airborne and on surfaces. But if not used properly, it can have negative impacts on chick health, particularly the chick respiratory system, which could then go on and influence your vaccination process, especially for our respiratory vaccines. But probably the bigger issue is formaldehyde is a known carcinogen for human health. It is one of the chemicals that is very closely watched by OSHA. It's very tightly controlled as far as biohazard status. And so there will become a time as we continue to move forward with our worker safety programs where using an aerosolized form of formaldehyde will not be allowed in our hatcheries. It has already occurred in some states in the US. And we feel like it's probably just a matter of time until it is more of a nationwide occurrence. So we are really trying to investigate alternatives for formaldehyde fogging that are still going to allow us to control those bacteria, control the fungus that may be present in our hatchery environments, while removing that potentially toxic compound.
Thank you for that overview, and it's quite interesting. It's my understanding that your experiments will not be limited to just the hatchery setting. You will also employ dry hydrogen peroxide on breeder farms as well. Is that right? And can you address your approach on the breeder farms?
Yes, that is correct. So one of the benefits of formaldehyde is that you can use a fairly concentrated form over a short period of time, just in that hatch window, to try to control whatever microbes may have been on the eggs that have grown inside any of the eggs that were potentially infertile, that would then bloom when the chicks start to hatch. One of the interesting aspects of this dry hydrogen peroxide technology, it is a very low concentration, which is what makes it safe for human occupied spaces. But because it is a low concentration, our contact time really needs to be extended. And so we are evaluating the dry hydrogen peroxide in starting on the egg coolers on the breeder farms as the very first contact point for those eggs as those eggs are being collected. We all know that as those eggs cool and those pores begin to close, that's a prime time for any bacteria that are on the surface of the eggshells to be drawn inside the egg and potentially contaminate the embryo or the allantoic fluid inside. So if we can begin targeting those microbes for destruction at that point, at our very first opportunity in the egg coolers on the breeder farms while they're stored there for a day or two, then in the egg coolers in the hatchery where those eggs may be stored for 12 to 72 hours, then in the incubators where we've got 18 days, then in the hatchers where we've got another 3 days, and we're combating the aerosolization of those bacteria as the chicks hatch, all the way through to sorting, separating, counting, processing, vaccinating, and getting those chicks onto the truck. That duration of that contact time, we feel like is going to give us the best opportunity to try to be the most effective at controlling those bacteria and fungus.
And what sort of sampling and data collection will be conducted to make your evaluations?
We're going to collect a range of samples, everything from actually swabbing the surfaces of eggs themselves and following different particular farms as we go through from the breeder farm to the egg cooler in the hatchery, to the incubators, to the hatchers. We're going to collect air samples from the hatchery, contact plate samples from the hatchery. We are going to do some swabbing in the hatchery as well on different surfaces, since we are treating a lot of the different places within the hatchery. Chick quality evaluations, looking at microbial load, fungal load in the lungs of newly hatched chicks and any retained yolks, yolk sacs that may be present, looking at breakout residue analysis, looking at just the normal hatchery parameters, what happens to the fertility or the hatchability, what happens to the hatch of fertile. That's actually been one metric that we've seen in previous trials on the hatchery scale that has actually really improved, is that hatchability and hatch of fertile number. So that's one thing we're going to be really interested in. But basically, we're just going to try to collect every sample that we can that relates to evaluating microbial load, how many microbes are present, what kind of fungus may be present, and then your typical hatchery parameters, what your hatchery is evaluated on, and compiling and collating all that data to pull out trends.
Very good. Now, can we get you to hypothesize what you think your findings might show?
Right. So we have done, like I said, this is sort of the culmination of a series of incremental experiments. And the last large trial that we did with the DHP, the dry hydrogen peroxide, was in a commercial hatchery where we just added the peroxide to the normal procedure in the hatchery. So that hatchery was using a formaldehyde fogging system, and we did not supply the dry hydrogen peroxide directly into the incubators and hatchers. It was just in the ambient space. And in that trial, we saw an improved hatchability, an improved hatch of fertile. We had decreased 3 and 7 day mortality in chicks that were hatched on the treated side of the hatchery. We saw reductions in fungal spores in the lungs when we did chick analysis. And so we would expect to see that same trend. Now, in this experiment, since we are completely removing formaldehyde fogging from one portion of the hatchery and replacing it with DHP, I would hypothesize that the DHP, the treated groups, would perform at least as well as the formaldehyde fogged groups, with the hope that they would perform even better, as we have seen in some of our previous work.
Well, I know myself as well as others will be waiting to find out if your hypothesis is correct. Last question for you, Brian. Is there anything else related to this work that you would like to share with the industry, or anything else to make the industry aware of?
Yeah, so we have done some studies in some commercial facilities outside the US as well, where formaldehyde fogging of eggs before they enter the incubator is a common practice. And we've done some direct comparisons to formaldehyde in that setting, where eggs were either formaldehyde fogged and then placed in an incubator, or eggs were not fogged and placed into an incubator that was supplied with DHP. And what we saw by 7 days after placing the eggs in the incubator, there was no difference in bacterial load, and the bacterial load was basically 0 on the eggs that we tested. So we have a pretty good indication there that the DHP supplied directly into those incubators does a very good job of really killing the microbial population on the surface of those eggs. And that's where we really wanted to move forward and expand on that to see how well that translated to total hatchery cleanliness and total chick health.
Well, this sounds very exciting, Brian, and I just want to thank you for taking a few minutes out of your day today to share with us the work that you have going on. I know myself, as well as others, will be anxiously awaiting your findings and look forward to you sharing that with the rest of the industry.
Absolutely.
So again, thank you very much. We appreciate it.
Thank you for having me.
Thank you.